Hello, and welcome to today's Parasoft webinar called Improve Software Quality with AI-powered API testing. Before we get started on today's presentation, let's begin with a brief overview of the Zoom webinar interface. Please use the Q&A window to submit your questions, and we'll be able to answer those at the end of the session. And please feel free to chat with the panelists and attendees in the webinar chat. Be sure to change the drop-down at the bottom to all panelists and attendees to share with the whole group. And as we usually do, we will provide the recording for this event. It will be emailed to you and posted online in a few days. Now let's move on to today's topic. I'm Joy Ruff, the Product Marketing Manager for the Parasoft Continuous Quality Suite. Joining me today is Chris Colosimo, the Product Manager for this product suite. In today's session, I will discuss the challenges of achieving software quality, and Chris will demonstrate how to optimize your testing practice and improve software quality with codeless API testing using AI-powered technology. Given the current state of the country and the world, I'm guessing that many of you are still working from home, as are your teammates. Keeping a team productive after an extended shift to a remote work model can be difficult. Perhaps you are experiencing some amount of COVID burnout after several months of limited activity outside of your home. Each person will be affected differently, but you may experience issues in one or more areas, such as emotional struggles, communication issues, access to information and infrastructure, and release coordination. If you're feeling isolated from the team, you may feel less motivated to be productive. If you don't feel like you were able to interact informally or with teammates or managers, you may not share necessary information or speak up to address issues. And it's easy to misunderstand or misinterpret someone's intentions if you're not able to see and hear them. You might also feel like you don't have an opportunity to provide feedback on release activities. If you're not comfortable with the collaborative tools, it can be difficult to ask for help or offer help to someone else on the team. Be sure to take time for yourself to keep your spirits up. Find ways to encourage your teammates and restore their sense of control. Share your knowledge and best practices to help the team work better together. Now, when you factor in the needs of the team, in addition to the individual, there are technology and business goals to consider. Remote and distributed teams, especially DevOps testing teams, must deal with many challenges to keep the projects running smoothly. Chris, can you describe that for us?
Absolutely. Thanks, Joy. Can you hear me okay?
Sure can.
So when we talk to the industry and we talk to our customers, given the complexity of the work environment that COVID brings in, there's also a challenge of the way that consumers are consuming the applications being provided. Things are shifting to a purely digital experience. Everything from getting some clothes or ordering some food, interacting with any of these organizations has now become a very digital, browser-based experience. So these organizations have to persevere. So they're shifting a lot of the activity to create these digital experiences for their customers because they have to be able to outpace the competition, especially now. One of the constraints with this is in the actual process of testing, because in many locations, local government policies have said that these resources can't actually work from home. Come into the office. They have to work from home, which means that they can't actually get the equipment to those testers. It constrains the resources. And so you have these two contending forces going against each other. So we see that organizations are forced to are forced into the modernization process. And it takes two forms. One, accelerating the way that the actual software is created and the platforms on which that software is developed. And that's why we see a lot of organizations moving to platforms like Salesforce, Guidewire, Mendex, all the ones that you see here. Because we don't have to worry about our servers. We can write our software and get a mobile experience with it. And so it allows us to quickly drop that software into the platform and deliver it. At the same time, we see the actual mechanics or logistics of the development, delivery, and testing process being moved into the cloud. We're seeing a rise in organizations moving into Azure, AWS, Azure DevOps, using things like Pivotal, Docker, all the things you see in the upper right-hand corner. What this leads to is more complex test environments, more environments that are in transition. And a key to a lot of this is that APIs are the web that connect all of these different pieces. So in addition to testing the application's digital experience, quality can become quite risky if we're not testing those API components. And so this applies an additional pressure onto an already constrained workforce. So Joy, maybe you can talk to us a little bit about the choices we have to make now.
Absolutely. Thanks, Chris. Given that APIs and integrated services are key to these complex enterprise applications, how do we ensure a successful testing practice? You've probably seen the messaging shown here that you can't have everything. Pick the 2 aspects you care about most and expect that the 3rd one cannot be achieved. However, this isn't really true. You can have them all if you do it right. Every organization has a choice to make, but rather than settle for 2 out of 3, you can work to balance them all. COVID may have changed the game, but you can still make it work in your favor. Proper rebalancing within your testing process can help to keep your quality at high levels. The key to unlocking this is test automation. Test automation is the only way you can efficiently verify functionality for the entire application. With test automation, you can run your tests quicker than you can by doing all your testing manually. Test automation is also cheaper. You will have an upfront cost to create your test automation workflow, but if you do it right, you can achieve a minimal amount of ongoing costs, resulting in lower long-term expenses, especially if you're using rapid agile development cycles. Also with test automation, you can focus on increasing your test coverage for your application. By using the testing pyramid, you can build your testable, scalable testing strategy. Ideally, you will invest the time and effort into unit testing and API testing to increase both code coverage and test coverage, while also incorporating automated UI testing and manual testing at an appropriate amount. At the base of the pyramid is the foundation of unit tests backed up by a solid set of API or service level tests. These tests are more efficient, so you should have more of them. These tests can be created earlier in the software development process. They're easier to automate and understand, and ultimately, they make it easier to diagnose the root causes of regressions and test failures. There's less of a focus on automated UI and manual tests in the pyramid. These tests have a purpose, and manual testing is very useful for exploratory and user experience testing, but they should be minimized as they are difficult to automate. They require access to the entire application and test environment, and they're difficult to maintain and diagnose. Following the pyramid as a blueprint helps you to create a test automation strategy that is scalable and repeatable. So to ensure your successful transformation, you need to understand how test automation fits into the continuous quality goal. The developer mindset, of course, is all about speed. Develop faster so you can move on to the next code. But to be most effective, testing needs to be aligned with development and provide fast, quick, and timely feedback. To enable true shift left within your Agile workflow, you need to embed testing into the entire software development lifecycle and ensure that it can be executed continuously and simultaneously throughout the process. By focusing on testing not only at the end of a release cycle or sprint, we are taking tests that are created once functionality is complete, fully automating them, and then executing them continuously moving forward as new functionality is created. This means you don't have to wait until the end of the next cycle to find any unintended changes in behavior. You can find those regressions as soon as they are introduced, and development can quickly identify the root causes to ultimately fix the problems quicker and therefore cheaper. However, many organizations are struggling with their testing strategy, which can cause them to fail on all 3 of these goals. They fail on the fast goal because they mostly focus on manual testing because it is quick upfront work, but it's time consuming to execute. They miss the manual testing. They miss the cheap goal because manual testing, although it has a low upfront cost, can't be fully automated or scaled for enterprise applications due to ongoing maintenance issues. And automated UI testing actually has a more expensive long-term cost because any test automation here is more brittle. For the good goal, you can't achieve maximum coverage just testing at the UI level because covering all of your use cases becomes very complex with all the different boundary conditions and environmental constraints. Basically, manual testing and UI testing aren't going to cut it for achieving software quality, even though most people are still primarily doing these. The sweet spot is API testing, which is what we're going to focus on today. To meet the software quality goals and the good goal, you need to be much more intelligent about how you leverage your cycles. API and unit tests help you meet the fast goal because they are quick to execute within a simple test environment. And the good goal, since they are more thorough tests focused on application functionality. These tests do require more technical expertise, but they're easy to automate and once established, easy to maintain for lower long-term costs. But as I mentioned, many organizations are still struggling with implementing end-to-end automated testing. While the testing pyramid shows the right way to approach testing, when we talk to actual people at real organizations, most of them identify with an ice cream cone rather than a pyramid with the inverted red triangle you see on top there. We find that many companies are using more manual or UI tests than API or unit tests, even though they are harder to automate. They're easier to understand and define with intuitive user interfaces, and therefore less technical and less expensive resources can do that testing. But when we dig a little deeper, we see that it's actually worse. We find that many organizations are skipping right past the API testing because it is hard to understand, and it often falls into a no man's land between dev and test teams. This ties back to what I mentioned earlier about having testing aligned with development within the CI/CD workflow so those teams can work in tandem. So Chris, if API testing really is the best solution, then why isn't everyone doing it?
Right. So what we find is that organizations, sorry, let me get this up here real quick. We find that organizations who want to bring in API testing, bring it in for the following reasons. It is one of the best sources of maintainable end-to-end automation. Quite often you think of a UI test as testing your application end-to-end. But really when we see the rise of microservices and different individual components that are communicating with each other, you can't 100% validate that you have all of the test coverage of each of the individual components individually and as they work together. API testing allows you to get that granular level of visibility. It also serves as a really good communication channel between dev and test. What that means is if I find a defect in QA and I hand you a UI test, and it turns out that that is something in the code, I have to peel back multiple layers of my application before I can find that. If I hand you an API test, I'm closer to the code, and it's easier to reproduce, it's easier to identify. And all that leads to shifting left the defect remediation process. But the reasons that we find that folks aren't doing it is because since there is no UI, APIs can be a little confusing. You have service definitions, you have PAT contracts, you have schemas, but that doesn't really tell you how the APIs work together. How do I collect up just the right APIs in the right sequence with the right data to accomplish the thing that I'm trying to do for my user story? Quite often it requires specialized skills and tools to hit all the right message formats and protocols in the right sequence to validate your application. And then Joy mentioned no man's land. This comes from some surveys that we were running where we were asking testers and developers, whose job is it to test the APIs? And we found that 40% of the testers were saying, hey, it's development's job. They wrote the Swagger, they wrote the open API spec. As they're writing those APIs, they should be having code level tests against them to validate their usage. But in that same survey, 60% of developers said, no, actually it's QA's job. because, you know, we publish the service spec. They need to then take those APIs and use them as the application would to validate the user stories. And so, you know, we know that it's actually a combination of the two, and each has their individual component, which I'll talk about during my demo. But it gets into that sort of weird, it's confusing piece of like, when do we actually approach this? We know that API testing is a solution, especially as we modernize our application, but the technical barriers tend to prohibit people from using it. But there are real values. And so Joy, I'm going to hand it back to you to talk us through those numbers.
Great, thanks, Chris. Yes, a key point here is that while API testing is more difficult, maybe more difficult, it's definitely worth the effort. API testing is part of the integration testing and ensures that the expected conditions for functionality, performance, security, and reliability are achieved. Excuse me. However, this recent API testing report shows that 2/3 of organizations reported that their dev and test teams spend less than 50% of their time on API testing, and that has a direct impact on software quality. Additionally, most organizations are not achieving sufficient test coverage. The API testing report also shows that 41% of organizations are able to achieve higher levels of test coverage with API testing, compared to 33% for unit testing and just 24% for automated UI testing. Stable quality code at the unit and API levels provides testers a solid foundation to ensure quality of the UI and the end-to-end needs of your customers. That same report also shows that automated API testing provides several significant benefits, including earlier defect detection, which translates into lower development costs, higher quality, resulting in a better deliverable, and improved time to market for faster delivery. A higher level of API test coverage helps you produce higher quality software. And that leads us into this slide. What is your level of API test coverage? According to another survey that we ran, we found that prior to implementing a codeless API testing solution, over 60% of the respondents had 40% or lower API test coverage. That low level of test coverage is going to impact software quality, and not in a good way. So over the past decade or so, we have witnessed this mindset shift among developers who want to develop software faster so they can get on with the job of developing more software. And that means that testing teams must take the leadership role in improving API test activities to achieve better test coverage and to understand and reduce overall risk, while also delivering on time. The movement to be faster has to be replaced with a strategic goal of quality in order to achieve all of the business goals. So with the need to ship quality products while maintaining the trifecta of fast, cheap, and good, API testing becomes more critical than ever. API testing is essential to ensure that solid foundation of software quality for your application, your organization, and your customers. Now, Chris, I'll hand it back over to you so you can show them how it's done.
Right. Thanks, Joy. So I think we've made the case for API testing as a valuable approach. How do we get there, though? So what I'm going to do now is I'm going to go through our demonstration portion, and I'm going to show you the two different approaches that we show to our enterprise customers when we start to onboard them with our codeless solution. Really, we want to think of API tests as two distinct types of tests: integration tests, component tests, which tests the individual API as a unit, testing for nominal and non-nominal data, and then integration tests, which tests each of those APIs as they're integrated together as a part of a moving system. There's two approaches. The bottom-up approach, as we like to call it, says let's test each API in isolation using a service definition or a schema, something for that individual service to ensure that it complies with the original design spec. And once we have validated those APIs in isolation, we then want to create scenario level tests where we can use combinations of different APIs in maybe one spec or across multiple specs to emulate how the application is going to be using those APIs. And so there's some techniques I'm going to show you for each of them and show you how AI can help us solve a lot of these challenges. So I'm going to show you three specific things here. The bottom-up approach, creating APIs by design. The top-down, where I create API tests by usage. And then I'm going to show how you can data drive the API scenarios to increase speed and also to increase coverage. And to do this, I'm going to use Parasoft SOA test. Parasoft SOA test is Parasoft's API testing solution. It solves the often daunting challenge of testing across multiple web protocols by supporting over 120 message types and formats. And the interface is completely codeless so that even non-technical users can get started. So what I want to do is I want to create some API tests for an application that I have. So let me go ahead and open that application. It's just a little banking application that we created. It has a series of services in it. Let me just go ahead and log in. The services allow me to do different things like open accounts, transfer funds, connect to third-party systems. The system has a series of services that are living inside of it that have some SOAP definitions, some open API definitions. And so I'm going to start here to create my test cases. So a test can consume any service definition from a RESTful or SOAP-based service and turn it into test clients. So let me go ahead and just open this. I'm going to go ahead and say, let's create a new test. We'll call this Parabank REST tests. And then I just choose the type of testing that I'm going to do here, whether I'm testing a RESTful service or a SOAP-based service with a WSDL or just schema, or intelligent traffic processing, which we'll talk about in the next section. Here I'm using an open API spec, so we'll go ahead and choose that. I'll provide the spec. Configure a default environment, which allows me to then run this across multiple environments by parameterizing certain endpoints, and there we go. SOA test as a codeless solution will create codeless clients that allow you to wrap the request and response information in a nice form UI that makes it really easy to interact with the elements that are required. So in this case, this is a call to get accounts. So I'll say, I know this is an account number here. We'll go ahead and fire this guy off. I'll get my response data either in JSON, or in this case, I'm using XML. And then from here, I can then go ahead and apply different regression controls to validate not only the content, but also to validate the structure, to validate the occurrence, to validate anything that I want about these individual services. I want to create a library of these services so that I can test individual pieces before I run my larger integration suites. Pretty simple, pretty straightforward. What I then want to do is take individual services and combine them together into a scenario. So let's say perhaps in this scenario, I want to grab a get account. I want to deposit some money into the account. I want to get the account again and then validate that the deposit took place. In that case, I would just copy those and paste them into another scenario here with my 3 services. And then I could run those services together. But anybody that's worked with APIs in the past knows, well, there's a little bit of a challenge with that, right? First off, I don't know if I have all of the right data. And furthermore, it can become difficult to exchange data between different services. Let me just make sure that I'm going here to the right endpoint. We'll go to my local service here. Just rerun that again real quick. Great. So what's happening in this case is I'm making a call. I'm getting the balance for this account 13344. And then what I want to do is I want to deposit some money into this, but I don't actually have that account ID. Now, potentially, I'm going to data drive this down the line. So what I really want to do is I want to link the account ID from this account to this account. And that's where the codeless aspect of SOA test really comes in. SOA test has over 75 plug-in tools that you can use to do things like looping, data extracting, encoding, signing payloads, transforming payloads, write data to a data source, pull it from it, do simple math. And this list of codeless tools is growing every day. In this particular case, I just want to grab some data from a response. So I'm going to go ahead and say, let's grab from the response. I'm going to grab the JSON or XML data. I'll get a nice UI that says, hey, this is the response that comes back. Let's go ahead and grab that ID. We'll assign it to a variable. And now I can use that variable in my subsequent tests. And you can see how going forward, you could create a really nice parameterized dynamic test that uses data in a very simple way. The other thing that I want to do when I deposit data is I want to potentially deposit a data-driven amount or maybe a random amount. In this case, I just want to show one tool that's really an MVP in our arsenal, and that's the data generator tool. We have a test data management infrastructure, but sometimes you don't need that horsepower. Maybe you just want to generate a random number and say maybe sometimes it'll be between $100 and $1,000. Maybe it's just a random social security number that I want to generate, a phone number. This tool allows us to generate random strings, numbers, and then use those in our test cases. So let me just actually bring this guy here. We'll go ahead and generate that value. And then in this test case, the deposit, we'll go ahead and use that parameterized balance. There's a lot more that you can do with an ecosystem like this, but this allows us to create really, dynamic and interesting sequences of API calls in a very codeless way and validate those flows. And so that's the bottom-up approach, which is creation by design. What I now want to do is talk about the top-down approach, because in the bottom-up approach, what becomes important is understanding those sequence flows. And if I don't really know how the application is putting those together, I can use AI to help me discover and create them. So what I'm going to do is I'm going to do that again. I'm going to go through a workflow, but this time I'm going to use Parasoft's recorder to record the API traffic that takes place with my application. Depending upon the application that you're testing, you might want to choose different options for, say, enterprise applications. You also have the ability to record pure Selenium scripts, but that's another webinar. So here I'm just going to choose general application type, start recording, let that think for a second, and now I'm going to go through my use case. This is a really great approach because you can look at your user stories inside of your requirements management system and say, okay, today they added a new flow, which is the find transactions. All right, so I'm going to go into find transactions and I'm going to validate that I can find a transaction with the amount 100. Okay, no transactions. That's fine. I'm then going to go ahead and go back to my accounts overview and stop my recording. This is now going to look at the traffic and it's going to use AI to establish relationships and patterns in that traffic. It's not just simple record and playback. Let's call this Parabank accounts transactions. I said that this was associated with a requirement in my JIRA. So we'll go ahead and say it's associated with this Parabank project, and this is 2323. I want that so that I can ultimately understand when these tests are created, what they're associated with. Okay, the system is thought. It's gone ahead and created a test for me. Let's go ahead and dive in. The tests actually show up in my little user area down here under Chris. There it is. There's my new test. And so this test was just created using that AI. And I can run this test, okay? And the test is successful, even though there's a lot of data that's being exchanged. And let's dig into this a little bit. If I go ahead and expand this test, you'll see that there are a series of smart tools that were created. A smart JSON data bank. What's this guy doing? This one is pulling in customer ID and the ID of the account, and then parameterizing that probably in later sequences when it comes to filling in the actual data in the account. Here's one. And you'll see that parameterization and a beginning assertion process is taking place from the AI because it understands some of the dynamic data in those APIs and starts to stitch that together. This is a really great way to get started in API testing because we can now start to learn the different APIs that are being used as we're interacting with our application. Now let's say that the AI does something wrong. What we can do is we can correct it and say, well, you know what, actually what needed to happen here was that I needed some authentication. Let's say in this case, for this particular API, I needed some basic auth. We'll just kind of toss this guy in here. Okay, that's the right way to interact with that. You can then train the underlying AI and have it learn the new rules so that on subsequent recordings, it will bring in these new rules and create better API tests. All of that lands into our brain, which is here in the smart test template, that allows us to define the APIs and the rules associated with those APIs. It makes onboarding new members easy because your testing tool is working for you. And it also allows you a way to templatize API usage and rules so that you can create a nice API testing practice, even when you don't know a ton about the application. There's a lot more to that, but I recommend viewing our YouTube channel to see some of that in action. The final thing that I want to talk about is coverage. Now, how do you know when you're done API testing? It's a super question that we get asked from a lot of our customers. And we believe it's a combination of requirements coverage, API coverage, and code coverage. Code coverage and requirements coverage is easy to understand because if you have tests for each of your requirements and they're covering all of the acceptance criteria, fine, you're done there. Code coverage, you choose a number, and if you achieve that number, you're done. But how do you know that you've covered all your APIs? Well, so a test, when you execute tests, can provide that number to you. So let me go ahead and just move this into my primary suite here. Paste. Okay, and let's say that I wanted to run this, my scenario, and a SOAP test. Can run these guys together. Check, 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 okay? And if I go ahead and look at the SOA test report, one of the things that I get is a coverage indicator. So here's a SOA test report, and obviously it tells me what tests executed against which requirements and how they're associated to my requirements management system. I get my traffic for all of my calls, but I also get coverage information. In this case, it says that 16 of 16 tests executed. However, that only represents 58% of my total API surface. Now, while I may have tests that fail, and that's important for me to dig into, these gaps in coverage actually should present a larger concern for me because I'm not doing any unit or API level testing against my stock positions, those microservices. I'm not doing any API level testing against these transactions. And so I want to fill those gaps. And this allows me to understand where those gaps are and how to fill them. Now, we went through the AI portion pretty quickly there, but I want to talk about what just happened. So the Parasoft Recorder plugs into your Chrome browser, and it allows both API testers and non-testers, such as your manual testers, to record their scenarios in the browser. We'll then record those transactions that take place between the browser and your front-end services, and we'll use AI to construct API test scenarios. We can do this as you're interacting with the browser, but we can also convert your Selenium test scripts into API tests. Because if you have a lot of Selenium test scripts, that's gold that's waiting for you from an API perspective. Then you can run those tests together and get double coverage, my API and my UI, and you can run those tests and understand where the bugs are being introduced and really cut down that defect remediation time. Okay, speaking of cutting down time, we've talked about the bottom-up approach, which is creation by design. Take your contracts, create API tests for them, create your assertions, control your flow logic, and ensure that individual services are structurally, semantically, and from a data perspective, complying to your original spec. You can then take the top-down approach to emulate use cases in your application, grab those API tests, and validate those use cases from an API perspective. APIs are not only more robust and stable than UI tests, they execute much faster. And so this is a really great approach. Final thing that you want to do is data drive all these different scenarios. By data driving the individual scenarios, you can increase test coverage by ensuring that you're testing both your positive and negative, nominal and non-nominal data, but also validating in a system like Salesforce, which is what we're about to look at, that you're hitting all the different data objects in the application and reducing that total execution time. So when it comes to data driving, you can actually use a combination of the top-down and bottom-up approach. And so in this scenario, what I did was I recorded Salesforce authenticating and then creating a contact. Now, once I had that sequence of events, I was then able to leverage the create contact to iterate contact creation. I added a data source. Let's look at data sources real quick. So a test supports many data sources, CSV, Excel, connecting to a live database, an in-table project. We can combine data sources together and loop on them in different ways. We also have the Parasoft data source, which is the data repository, which allows us to connect into our test data management infrastructure and generate all sorts of data for our test cases on the fly. In this case, I have created a simple in-table project where I'm going to create some contacts. I'm a big fan of The Simpsons, so I'm going to be creating some Simpsons characters. I've created these Simpsons characters as well as using that good old data generator tool to generate a phone number. I then create an object for contacts and load that object with data. I got this from recording the transaction. And then I simply loop through the creation. The net is that it gives me the ability to create many contacts at once in my Salesforce application and then subsequently delete those. So let me just refresh this list here real quick, make sure I'm still logged into Salesforce. Okay, so here's my contacts. So now what I'm going to do is go back into SOA test and I'll go ahead and execute this test. From here, the thing that I want to point out is the execution time. So now we're going through authentication. That took 6 seconds. Now we're loading up that first data object. And now we're going to start iterating through creating all those different Simpsons characters. 23, 26, one more set, 27. Total execution time, 18 seconds. If I go back into my Salesforce infrastructure, I've created those contacts. I simultaneously validated the objects when they came back. And this allows me to rapid fire through my applications, be they enterprise applications or general applications. And this serves as a much faster and more reliable method for validating applications than just a pure UI test. Because to execute each one of those tests by data driving a UI test would have taken extra time. And you know, we have tens of thousands of tests that we need to execute in order to validate our application. So these tricks really help us out. Okay, so those are our 3 different techniques for testing the application. And our customers use these to solve many challenges. You know, yeah, we want to get greater coverage. We want to get greater confidence. We want to understand our API infrastructure, as well as understand hidden and undocumented APIs. And the recorder and the AI is a really good way to sniff those out and to create nice, rich tests to help us get that confidence that we're covering everything. Because remember, even an undocumented API is an attack surface for somebody outside of our organization. So we want to know what those are, and we want to be able to test those. The other thing that this allows us to do is to reduce tester fatigue. This is something that at Parasoft we believe is really important. When you're moving to a digital delivery system, you may be introducing hundreds, if not thousands, of APIs at once. And the tester looks at that and it's a giant mountain. Where do we start? And by using the bottom up and the top down approach, it gives us a process where not only can we leverage existing tests that have been created, maybe leverage those Selenium tests that have been created, but also create a nice collaborative process through our AI learning system to really start carving off chunks of that API infrastructure. And it makes that process a lot less daunting, and it creates less API tester fatigue. Obviously, test data can be simplified, especially in combination with service virtualization, which is another topic, but we can mock out data for our services. And API tests really take a good advantage from virtual data because you control the infrastructure. Obviously, allowing earlier access through service virtualization, reduce wasting cycles by ensuring that the application's UI, you don't go all the way through the end, test the UI, find there's a problem with some API. You can actually do API testing before the UI is even available. And then all of that leads to reduced testing costs. So Joy, I'm gonna hand it back to you to talk about how we can achieve our goals with testing.
Oh, thanks for the great demonstration, Chris. So now you all can see that by doing effective automated testing, you can achieve better quality, reduce the cost of development, and deliver your software on time, meeting all of your business goals. Distributed and remote agile software development teams need a flexible testing strategy that enables them to meet their user expectations for high quality experiences and reduce the risk of them switching software. End-to-end test automation makes all this possible to achieve both business and quality goals by streamlining your testing and aligning it with the development process. Automated API testing specifically is a crucial component of an end-to-end testing strategy to deliver on the size, scale, and complexity of today's applications. You've got to do more than UI testing to thoroughly validate your application. You need to integrate AI-powered API testing along with unit and UI testing to deliver high-quality applications. So look for innovation and advancement in the modern tools, leveraging AI and machine learning to enhance your test automation activities. A good end-to-end low-code testing strategy will result in high-quality software with fewer defects and faster deliveries, which is a plus for the bottom line. To wrap this up, if you are ready to select your codeless API testing tools, check out our white paper on considerations for choosing the right API testing solution. And you may also want to evaluate service virtualization options to ensure your team can deploy and access test environments for services that may be unavailable or unstable. So now we will take your questions about the content of today's presentation. Please submit your questions in the Zoom Q&A box. And Chris, why don't you let us know which questions you want to address first?
Yeah, we got some, thanks Joy. We got some really great questions here. Thank you guys for submitting these. I'm just gonna go through these in order because I think they're all great. So let's start with the first one. Would it be possible to do consumer contract validations? If yes, what would be the workflow? So absolutely yes, contract testing, especially at the API layer, is critical when you start thinking about microservices and you start thinking about event-driven architectures. So your contract can take a couple different forms. You can have a pact, you can have service definitions, and we also see a lot of organizations that deal purely in schemas. All three of those are consumable by Parasoft. The workflow would be that it's two-part. One, that organizations create virtual services for their services that they're creating. Those virtual services, which just think of them as intelligent mocks and stubs, those get checked into source control and ultimately deployed as a part of the environment architecture. From that, other integration systems can test or integrate with the virtual service to ensure that they are they can consume it, they have the right structure, they can handle the response that comes back, and vice versa. If those systems go both ways, everybody gets their own virtual service. Additionally, by taking those schemas, those contracts, you can then create test clients from those to ensure that those test clients can consume the real service. And you run those in regression as a part of an automated, either nightly system or as a post-commit trigger when you check your code into source control, right? This service changed. Let's go ahead and run all those test clients against the real services. Those real services called the mock services. Everything gets validated. The final thing is through our change advisor workflow. We have a system that allows you to take two service definitions, two schemas, compare them to each other. It uses AI to determine what the changes are. You know, we have a second. I can actually show you that. We're a little ahead of time. That looks like, let's find that real quick here. That looks like this. Jump in here to the service definition. Change management console. Here's all my service definitions. Here's a change template. And the change template basically says, okay, these are the two services. This is how it's changed, like the names changed here. Also, we see those individual schemas so we can understand, you know, what needs to change and then automatically update our tests. It's a very nice system for not only identifying the change, but remediating the change. So really, really good question. Okay, second question. Would it be possible to run tests on any new Swagger, assuming changes in the new version, checked into source control, essentially running already created tests on a Swagger from source control? Yeah, so you would run your API tests as immediate tests on check-in and a part of nightly. You could also run diff controls on the service definition itself, or you could leverage the change management system that I just showed. Understanding, identifying, and quickly remediating change is the greatest unblocker to API testing, especially when you want to keep your teams in codeless solutions. That change can just be a killer if you've got scripts. So codeless can really benefit from that. How are we making sure the password is encrypted? Well, there's a couple of different ways you can do that. One, you can make positive and negative tests to validate the content of the password over the wire. And if the password isn't decryptable, then you know it's not encrypted. The second technique is you can send a plain text password as a part of your negative test scenario, and you would expect that that would be rejected. So there's a lot of ways to do that. How do you configure, these are great questions, by the way. How do you configure your suites to say include, exclude tests? Great question. So there's two techniques. The tool that you saw, we just showed the desktop client. There's a whole server infrastructure that allows you to run your tests as a part of your CI process or as a part of your DevOps ecosystem through REST APIs. Either way, the CI execution, which is command line, or the DevOps integration, which is via REST APIs inside a SOA test, the execution commands have includes and excludes parameters. And you just simply define what resources you want to execute by name, by folder, or you can do the opposite and say execute everything, but exclude tests that have this pattern. Support for CI/CD integration. Yeah, so because of the two things that I just described, so it just can be run from your CI infrastructure, either by using the command line or the REST APIs, or we provide a whole bunch of native plugins. We have them for Jenkins, Bamboo, TeamCity, Azure VSTS. That list grows every single day. And just a real quick conversation on that. We believe that you should run your tests from the bottom up, static analysis, then run your unit testing as a function of as a post commit function when you check in your code. Then run your API tests, then run your API integration tests, then run your UI tests. The idea is you want to fail fast, fail early. If you have static code violations, you want to figure that out. You want to stop execution, fix that problem. You can actually run those as you're writing the code. Again, another subject. But then run those API component and integration tests as a build step in your build system. Because if those APIs are misfiring or not complying to your expectations, what's the point of running a UI test, right? That's how you really start saving those times. You can also combine that with Parasoft's smart test execution, which includes test impact analysis. so that we can identify when the code changes, either through scanning code sources or by looking at your binary WAR file or jar file. We can identify which API tests, unit tests, and Selenium tests need to execute to even further hammer down that time. But yeah, very deep DevOps integration. Contact us. I think that's a really good conversation point. It's something that we've really strove to really build the solution to be very cloud and DevOps friendly. Here's another question, load testing capability. Absolutely. We looked at Parasoft SOA test today. Parasoft SOA test also has Parasoft load test. Parasoft load test is our load and performance testing solution. Great thing is they're kind of the same tool. So anything you create in SOA test, you can run in load test, even if it's a microservice protocol. You can run them under load with different control parameters, such as number of virtual users, number of threads, number of transactions per second, and get really nice, rich, detailed reports about your SLAs, not only individual SLA confirmation, but also SLAs over time. Okay, wow, they just keep coming in. How are we on time? Oh, we're doing great. Are we able to connect to a DB2 system to fetch data and then run your API? Do we need to install any driver for the same DB2 database if it's placed on a server or remote machine? SOA test can absolutely communicate with databases. SOA test can communicate with any database that's JDBC compliant. All you have to do is add the native drivers for the database into SOA test. We have a codeless tool that allows you to define the class and the URL for the database. The B2 has JDBC interfaces. You can then commit a SQL query to the database, whether it's regular or a stored procedure, doesn't matter. The response then comes back. You can then either validate that as a part of an omni-channel or end-to-end test, or you can use that data to then stuff into an API, or even vice versa, call an API, call a web component, stuff that into a database. It's all just like little Lego pieces that you can plug together. And it doesn't matter whether it's on a local or remote machine. Okay, I have a question here about manual testing. So I'm going to skip a couple of these, but I do want to cover this one because it's close to my heart because I'm a tester. Will manual testing ever go away completely? Come on.
Chris, your audio is breaking up a little bit.
All right, let me do this. Is that better?
Yes.
Okay, sorry about that.
The topic near and dear to your heart.
It's a question near and dear to my heart. Will manual testing ever go away? And I mean, come on, right? Manual testing is one of the most essential testing practices that we have. There are things that machines will never be able to validate, like look and feel and just personal experience and how you interact with an application. Manual testing is essential to a testing process, but manual testers need to focus on what manual testing is designed for, which is completely unexpected and, you know, strange corner case things and just quick validation. And so automation should support manual testing and take away all the other noise and extra work that manual testers are doing now. You know, a manual tester should only ever have to test something once. And then they come and they test something else. And then they test something else. And everything else runs in automation so that you can continue to run that as a regression. No, manual testing will never go away. AI can support manual testing by understanding what it is that we're touching and converting that into UI, API, and so on. Okay, I do want to answer this question. Tell me something that SOA test can't do. I actually really like this question because it means that somebody's enjoying looking at this tool. You know, SOA test is really a codeless API testing tool. There is a mobile component, there is a UI component, but we believe that Appium and Selenium are the techniques for testing UIs and mobile devices. Now, we do have a solution for writing Selenium scripts. It's pretty cool. It's called Parasoft Selenic. But we leverage other organizations to write mobile tests. We believe instead that once you have your mobile tests, your Appium scripts, you then hijack the API calls that are made to the mobile device, because you know that mobile app or that native experience is only part of the problem. It's the integration with the backend APIs. And whether you're using a standard HTTP message formatter protocol or something like a RabbitMQ or even something more sophisticated, we want to test those APIs. So how do we get our hands on this? You can go to either of these links, scan one of these barcodes, or go to parasoft.com and check out SOA test to get a trial and a demonstration. And I think, Joy, I think that's it.
I think so. Thank you everyone for the great questions, and thank you, Chris, for the wonderful demonstration and presentation. I think that it's been a really good session today. So we appreciate your time, and please feel free to come check out other webinars at parasoft.com. We have an abundance of resources available as well, white papers, blog posts, and we have a user forum that you can check out. If you'd like to get more information, feel free to come to parasoft.com and we can set you up with a live demo or a trial for any of our products. So again, thank you for your time, and we'll see you on the next session. Have a great day.